Welcome to the Information Systems for Business podcast. The main purpose of the podcast is to augment the book Information Systems for Business, An Experiential Approach, 5th edition, by Frans Belanger, Craig Van Slyke, and Rob Crossler. The book is published by Prospect Press. I'm your host, Craig Van Slyke. This episode is for the 5th edition of the textbook. Before we get started, I wanted to give a couple of disclaimers. The podcast purposely omits many details to get to the high points of each chapter, so listening to the podcast is not a substitute for reading the book. Each episode contains my view of the most important points of each chapter. Your professor may have a different view of what's important. The podcast is solely my responsibility, so any errors are on me, not my co-authors, your professors, Prospect Press, or my employer. All right, enough with the disclaimers. Let's get to the good stuff. This episode covers the most important points from Chapter 5, Information and Knowledge for Business Decision-Making. The focusing story for Chapter 5 relates to a true story of the first time I heard of workers using text messages to manage and share knowledge. The story is about some programmers who frequently texted each other to ask for help on troubleshooting their programming code. This is pretty common today, but back then it was very innovative. We often want to tap into the knowledge of others, and information technology makes it easier than ever to do so, whether it's a formal support website, AI, social media such as Reddit or Facebook, or simply text messaging. The success of a business relies heavily on how well its employees can apply knowledge to make decisions and solve problems. Chapter 5 helps you understand how knowledge is managed and how technologies can help organizations manage and apply knowledge. The chapter also covers decision support systems and business analytics systems. After the focusing story, Chapter 5 discusses the importance of managing knowledge. This is followed by a brief discussion of different types of knowledge. Next, the chapter goes into some details about the main processes involved in knowledge management. An overview of some important knowledge management technologies follows. Chapter 5 then moves on to a discussion of decision support systems and collaboration systems. This is followed by a section on business analytics. The chapter closes with an overview of artificial intelligence. Here are the main points from Chapter 5. Managing knowledge is more complicated than managing data or information because knowledge is often hard to structure, difficult to capture, and hard to transfer from one person to another. Knowledge management is a process that allows organizations to generate value from their knowledge-based assets. Knowledge management involves capturing and documenting what employees and other stakeholders know, and then developing systems that make it easier to share and use that knowledge. Knowledge is a critical organizational resource, so managing it is also critical. Effective knowledge management can help improve problem solving, customer service, and innovation, and can make processes more efficient and effective. See the chapter for even more benefits. Broadly speaking, there are two types of knowledge. Explicit knowledge is relatively easy to express. Often explicit knowledge is stored in things like operations manuals, books, and articles. Implicit knowledge is difficult to express or communicate because it's internalized and highly individualized. Implicit knowledge is sometimes called tacit knowledge, and it's deeply rooted in our life experiences, values, and biases. For example, a great artist might be able to create beautiful works of art, but probably can't clearly communicate how they accomplish this. There are 7 main processes for knowledge management: creating, capturing, codifying, storing, retrieving, transferring, and applying knowledge. Creating knowledge is done through a continuous process of interaction between implicit and explicit knowledge. This is kind of hard to explain without a diagram, so check out Figure 5.2 and the associated text. Capturing and codifying knowledge involves acquiring the information, then putting it into a usable form. Putting it into the usable form is what we call codifying knowledge. Although it's hard to codify knowledge, tools such as cognitive maps, decision tables, and decision trees can help. See Figures 5.3, 5.4, and 5.5 for examples of these. Storing and retrieving knowledge is also challenging because knowledge can take so many different forms. Resources such as a well-organized corporate directory that lists everyone's areas of expertise can help, as can a searchable document storage system. To be useful, knowledge needs to be applied, which means that knowledge needs to be available to those who need it when they need it. Often this involves transferring knowledge from one individual to others. Education is one example of knowledge transfer. So is asking a friend for help on a project or assignment. There are technologies that can help with knowledge management. Knowledge repositories make it easy to find and retrieve documents that contain knowledge. Communications-based tools such as email, collaboration tools like Google Docs and others, Zoom, for example, and social networking tools like Slack and Discord can be useful. Social networking tools make it easier to build communities of practice, which are groups of people who share a common interest and interact to share their knowledge. Digital dashboards can also be helpful. Expert systems help users solve problems in a way that mimics an expert's thought processes. Decision support systems are computer-based systems that help decision-makers use data and models to solve semi-structured or unstructured problems. We can divide decision support systems into four main categories. Data-driven decision support systems focus on the retrieval and manipulation of data. Data warehouses are important parts of data-driven decision support systems. Model-driven decision support systems focus on giving decision-makers the ability to access and manipulate analytical models. Document-driven decision support systems focus on managing and retrieving documents that might be helpful to decision-making. Communication-driven decision support systems facilitate collaboration and group-based decision-making. Collaboration systems, which are sometimes called groupware or team support systems, are network-based systems that help groups communicate and collaborate. There are a lot of different types of collaboration systems, such as group decision support systems, which allow for things like brainstorming, anonymous commenting, and voting. Shared whiteboards that allow users to share drawings and annotations and support real-time collaborative editing. Video conferencing systems such as Zoom and Microsoft Teams, and chat systems. And these are all often kind of put together, like Zoom has a whiteboard function and chat and that sort of thing. So these sometimes come bundled into one overall system. Business analytics is the process of transforming data into insights to improve operations and decision-making. Business analytics is similar to business intelligence, although there are some technical differences. Data warehouses are critical elements of many business analytics systems. Data warehouses store and organize data in a way that's better suited to supporting decision-making than operational systems are. Data warehouses have several distinguishing characteristics. They're subject-oriented, which means they are organized around particular subjects such as marketing or human resources. The data in data warehouses are integrated from a variety of sources. Data in data warehouses are usually transformed in some way, for example, by being aggregated, like getting a mean or a sum. Data in data warehouses are typically non-volatile, which means that the data do not change once they're in the data warehouse. Data from various sources are gathered, prepared, and loaded through a process called the extract, transform, and load process. This is often called the ETL process. Check out the chapter for descriptions of each element of the ETL process. We can categorize business analytics goals into three categories: descriptive, predictive, and prescriptive analytics. Table 5.3 has more details. Yeah, you still got to check out the book. Data mining is the process of analyzing data to identify trends, patterns, and other useful information, typically by using statistical techniques. See Table 5.4 for some examples. Artificial intelligence refers to a family of technologies that approximate human cognitive abilities. Machine learning is a major branch of AI that involves developing applications that automatically improve through experience. See the chapter for more information, including some pretty interesting applications of AI. That's it for Chapter 5. I'll say it, I'll always say it. Be sure to read the book. Talk to you next time.